Hi there. In this video we're going to look at more properties of logarithms, also useful for solving equations using logarithms, and we're going to continue our discussion of these properties and rules with a discussion of the quotient rule for logarithms. And like the product rule, we're going to first explore or recall what the quotient rule of exponents is. Do you remember? It kind of looked like something like this. B raised to the m divided by b raised to the n. Notice that in our fraction, both exponents have the same base. This is equal to b raised to the m minus n. Okay, so we have something very similar when we are talking about the quotient rule. When we are talking about the quotient rule, we have something that kind of looks like this. Log base b of m divided by n, that is equal to log base b of m minus log base b of n. Okay, so we can employ this rule in breaking a quotient apart, or taking two logarithms that are separated by a subtraction sign and combining them into a single logarithm. And we'll do more with that a little bit later. Okay, so let's start with some examples. I have 5 examples here for you. Here are the first 2. Log base 7 of 7 divided by x. Okay, so we have a quotient, which means we can break this apart into 2 different logarithms separated by a subtraction sign. So we have log base 7 of 7 minus log base 7 of x. And now we notice that log base 7 of 7 can be simplified, and it does in fact simplify to just the value 1. And so this goes just a little bit further, and we say this is equivalent to 1 minus log base 7 of x. Okay, so we continue this idea with the next example, log base 4 of 64 divided by x. Okay, and again we see a quotient, so we can separate this into 2 different logs separated by a subtraction sign. Notice the numerator is the positive piece. The denominator is the negative piece when we are subtracting. Okay, and looking at these 2 logarithms, we recognize that 64 is indeed a power of 4, so this expression can be simplified to just 3. So 3 minus log base 4 of x. All right, moving on. We look at the next couple here. Let's look at this one. Notice there's no base here. Ooh, what does that mean? So we're going to look at this. We're going to say this is log of x minus log of 1,000. Recall, when there's no base written explicitly, it means that the base is 10. And so this piece here does not simplify, but this one does, because we know that 1,000 is a power of our invisible base of 10. In fact, this is the number 3. So log of x minus 3. All right, now we're going to continue. We've got 2 more examples here. All right, so this one is, again, a division. So log of 100 And we're going to subtract from that the log of x plus y. Okay, so recognizing that 100 is a power of our invisible base of 10, this simplifies to 2 minus log of x plus y. And it is very tempting to want to break this apart into two separate logs. But recall that we have already talked about the product rule, where we can break apart a product. We cannot break apart a sum. So it's very important that we leave this alone. We do not try to break this apart. And this is as far as this one can go. And our last example here is ln of e to the 5th minus ln of 3. And remember, when we see ln, this means log base e. So this is log base e of e to the 5th minus log base e of 3. This piece does not simplify at all, but this one does. Okay, so what power of e is e to the 5th? Well, it's kind of a silly question, because that, of course, would be 5. 5 minus ln of 3 would be our simplification here. Okay, and that's it for the quotient rule of logarithms. We'll see you next time.